Hello, this is a DivvyCon podcast about CASON's gas network monitoring application. When we talk about gas network monitoring, we're talking about the supervision of an entire gas transportation or distribution network, everything from the pressure valves to the entire network as a whole. I would say that this monitoring application is for the supporting of hydraulic supervision of the network. People who work for these network operation companies know that the worst situation is when something has happened within the system and there is no available information, just angry customers who demand the re-establishment of their service. Here we can see a typical gas pressure regulation station, a cabinet plant type. Similar facilities can be found all over the world. You probably will not find power or communication cables in the field. Yes, this is a big challenge because all the electronic devices installed have to run on battery power. To make the situation even more difficult, the area around the cabinet is an explosion hazard zone, so you can only install devices with explosion-proof design. It may seem impossible to meet these criteria, but I will show you how easy it can be to do it. In this case, pressure regulation essentially means pressure reduction, because the main task of the station is to reduce the pressure of the transportation pipeline between the pipe and the end user in a regulated way. That's why these facilities are often called pressure reduction skids. The gas flow from the transportation pipeline comes from underground, the ochre pipe. This is a common facility with two rails, primary and secondary. There are filters and two pressure regulators with pilot valves. The DW628 field controller is quite unique. The device has an explosion-proof design and uses built-in batteries, not just for its own operation, but also supplies the connected field sensors with power. In addition, the collected data is transferred to the central database using GPRS communication. And, due to the optimized event-based communication, the internal power supply allows independent functioning for up to 5 years, depending on the application. The installation of the field system is rather simple. Our Aladdin field controller, on the upper left side of the cabinet, is for collecting the process data. There are special low-power transducers installed in the cabinet. The DivvyCon pressure transmitter is connected to the process by a simple T connection. Pressure transmitters measure both the inlet and the outlet pressures. The inlet pressure is the pressure of the transportation pipeline. The outlet pressure is the regulated one. The state of the pilot valve is detected by the DivvyCon position sensors. I say sensors because the secondary rail has the same instruments. The signal is active when the regulator switches from the primary to the secondary rail, due to any kind of process or supply-related failure. Now we can see a very similar process on a display of a DivvyCon SCADA application. All the collected and processed data is on the screen. This is a trend diagram of the pressures, where you can see that the resolution is quite good. Now let's look at some of the benefits. First of all, the system provides a kind of remote presence. You do not have to be in the field. You have all the necessary information without being there personally. Secondly, it is not only easy to install, but easy to operate, because it has a high level of autonomy. Also, the supervision is online and documented. Online means the operators have all the necessary information to make decisions in time. Documented supervision means that all the collected and processed data is stored and can be used any time for analysis or even as proof of the system availability. All these useful features greatly improve the service quality. So to sum it up, let's repeat the main message. I've divided them into 3 blocks from the point of view of installation, operation, and security. I think the final result is optimized network operations, where all the necessary information is available without delay, where the troubleshooting time is minimized, where the system operates using the optimal parameters without unnecessary losses.